In this section, we're going to focus on Remainder Theorem. So when it comes to Remainder Theorem, all we're doing is using synthetic division, and then our answer is the remainder. So what remainder you have, that's your answer, period. So again, for Remainder Theorem, or if you have a problem and it asks you to use Remainder Theorem, all you're doing is using synthetic division, and then you find the remainder as your answer. So when it comes to division, synthetic or long, we have to make sure that all terms are there. So let's check. X to the third, that's where we start off. So it's there. So what comes next is the one that's one less of the exponents. So one less is the x squared. We have it. So we're good to go. Now what comes next is again one less of the exponent. So it should be x. I don't see it. So we have to rewrite it to include x. So we're going to start off with x to the third. We have minus 3x squared. And again, we didn't have an x, so we're going to use 0x. So plus 0x. We have a number, so we're good to go. So plus 2. Again, for something that's not there, we always use a number 0. So now we have all our terms. Now, x right here is just an invisible 1. So to make sure we all have it, look at the x one. So count down from 3. So 3, 2, 1, we're good to go. Especially when we have a number, which is the 2. Alright, now we're going to set up our work for synthetic division. And what's the difference is that we didn't have a factor. That's alright. We set the factor equal to 0 and find that 0, which is right here, k equals negative 2. So that's alright. So remainder theorem, you're given a polynomial function and a 0. So this, we're going to divide this whole function by that 0. So I'm going to set up our L table for synthetic division. Alright. I'm going to write down the negative 2, which goes right here. And then we're going to use the coefficients. So here was an invisible 1, so I'm going to write positive 1. We have minus 3, so that's going to be a negative 3. 0. And then we have that 2, so it goes here. And I'm going to write out the line for our work. Alright. Synthetic division. Again, when it comes to remainder theorem, we always use synthetic division. Always. First step is you bring the first number down. So 1. So negative 2 times 1, that's negative 2. So negative 2. Now we're going to start with the top. So negative 3 minus 2. So negative 3 minus 2 is just negative 5. Now, negative 2 times negative 5, that would become a positive 10. So, positive 10. And then 0 plus 10 is just 10. Now, negative 2 times 10, that's a negative 20. Alright, so 2 minus 20, that's a negative 18. There's nothing left to divide or multiply or do anything else. So we stop there. And this is our remainder right here. The last number is always the remainder. And since we're doing the remainder theorem, so our answer is just negative 18. So, negative 18. That's our answer. Again, remainder theorem, we always go for the remainder. For our second example, we have f of x equals x to the third minus x squared minus 2x. And since we're using division again, we gotta make sure we have our all of our terms, including the constant. So let's take a look. We have x to the third. What comes after is x squared, which we do have it, so good. And then after x squared is x. We do have that, so we're good with the x's. But let's check. What comes after x should be a constant number. We don't have a constant number. So what we're going to do, I'm going to rewrite it. So x to the third minus x squared minus 2x and plus 0. So we have all the x's and the constant. So we're good to go. Now we can start off with our synthetic division. And here, k equals 3, that's our 0. Alright. Draw the L table. Alright. So that 3 will go out here. And our first number, and again, the coefficient. So I'm going to underline all the coefficients. So here is the invisible 1. Here, since it's minus x squared, that means it's negative 1. And then since it's minus 2, so negative 2. And then that 0 right here. So we got all of our coefficients. So again, 3 from here, and then all of our coefficients. First step is you bring down the 1, well, the first number, so 1. So 3 times 1 is just 3. And then negative 1 plus that 3 is just 2. So 3 times 2 is 6. So negative 2 plus 6 is just 4. And then 3 times 4 is 12. And then 0 plus that 12 is just 12. Alright, that's the last number. There's nothing else we can do. So, again, that's the last number. And the last number is always the remainder. Or remainder. And since we're doing the remainder theorem, so our answer is just simply 12. So for this function, this question, our remainder is 12. That's all we have to do.